Clear? Okay. So if we go more in how we can do infrastructure asset management, the first thing to start with is you choose an asset, but it could be the same for an infrastructure, and you have this existing asset, maybe this detention basin that you have built, all new, and you are very happy with it. And you need to think, what do I want to do in 20 or 50 years? What do I want to do in long term? The same is if you buy a property, at some point you need to think of what do I want to do with this property on the long term. You're managing your asset, your property. You can choose to do nothing. You can choose to let the detention basin live its life. You reduce the cost because you don't inspect it, you don't maintain it, and so there will be very low cost. You don't know if it's working because you're not maintaining, and that may work. The same, you buy a property and you don't do works on the long term. That's a solution. I don't say there are good or bad solutions. It's more that you have to choose what you're doing, and you do it on purpose. You can choose to extend it. You will say, okay, I have built this system, but in 20 years, I want to have 10 times the size of the system because I know that there will be urban development and more impervious surface, so I need to manage more water. So my only aim is to build the same system more and more. Could be a solution. You can have your house and you decide to add part of this house. You can decide that maybe it was not so good to put it on the surface because it's not really nice and people will see it, and maybe I should hide it. So I will renew it in a few years and I will build the same detention system but underground. Could be a solution. Another solution can be to integrate it. Again, was not a good idea to put it like that because I want to increase my city's visibility and I want to make things nice. So I want to make it disappear. But I can put it underground to disappear, but I can also integrate it. Integrate it is, instead of having this detention basin that was built like that, I can have an infiltration basin and I will have the detention. I may add also the infiltration and it looks nicer. Or if I want to keep the detention basin, I can think of the city is building, so if I take this space only for the detention basin, I'm losing lots of space in the city, lots of expensive space. And this detention basin, according to the design, may be full only once every 20 years, or 10 years, or 30 years, depending on your calculation. So it means that it's fully used every 30 years. So that's not so good if you buy something and you use it only fully every 30 years. So you can think of, instead of hiding, changing, I can add more service with that. So I will put sport field and basketball or soccer or tennis or whatever. And when there will be a heavy rain, I can put a system to alert the people that this will be flooded. I can put good evacuation. I can deal with that. It's not so complicated. And so most of the time it will be a sport field. But when it's raining a lot, not many people are doing sport outside. So that's a good time to use this system for detention and flood protection. And so it may work somewhere, but if you put that in a countryside far from any cities, nobody will go there to play sport. So you have to think also of where you're doing that. Another option. And then another option will be, I know that there will be urban development and I will need more system. And maybe it's not good to extend it, maybe it's not good to do that. I will adapt it. So I will keep it, or part of it, and I will combine it with other different systems. And I will do maybe this detention basin, and after that I will do infiltration or swale, and I will combine. And maybe if I'm combining them, the system, they will be used more often because they will be smaller system and as they are adapted, they can cope with different sizes of rain, and it could be more efficient. And there is no one solution fits all. This is really dependent on the surrounding, the expectation, and so on. So you have to think of that for all of your system. But before thinking of all of that for all your system, you have to also think of the whole system, where you want to go. Do you want to go in some more green space, encouraging biodiversity and so on? Or do you want to go in everything hidden and build? So you have also to choose not only at the asset level. When you've done that, then the steps are very classical, and so we will go one by one. It's often a 6-step to do the asset management of your system, and this will be based on your tactical choice, and you will apply this every year. And this should be in correlation with your tactical objective. So the first part is to increase the knowledge, then to choose where to investigate, to know the condition of the asset and what will be the consequence of this condition, to decide what you want to do the job, rehabilitation and so on, and very important, to control the quality. The first one, increasing the knowledge, is the basis, and it's very important. If you don't start with that, you won't go very far. The first thing that many utilities don't know now, don't often know now, is where all their assets are and how the component, what are the components of their assets, what are the surrounding of this asset, and what is the existing condition. Some first WSUD have been built maybe 20, 30 years ago, and when they were built here, there. They are not connecting infrastructure compared to other infrastructure. So when they have been built, maybe this knowledge of where and how they have been built has been lost. So if you don't know where your assets are, it will be very difficult to start to work at the whole asset scale. So you need to know the location, composition, surrounding. And then you need to find information on the existing condition, because there are too many assets, so you cannot inspect all of the assets. So you need to find data that will help you to know the existing condition. Maybe there has been some investigation. Maybe you have complaints from inhabitants. Maybe in this district where there has been this infiltration basin since 10 years, there are lots of complaints. Every rain, they are flooding and people are not happy because this and that. So maybe it's a good start to go there and see what's happening. And based on that, you will choose what and when you want to monitor the system. Where are your priorities and when can you do it based on your resources? When you monitor a system, I call that monitor, but it's lots of things inside. When you go and see the system, you have very different level of inspection of a system. You can go and have a visual inspection. That's very often done. Someone will go and have a look. Is it clean? No flooding? No litter? Nothing? Okay, that's good. And sometimes they will have a form to fill. This has been inspected, good, good, good. And it's only visual inspection. And we saw before that infrastructure are often hidden, so visual is not enough. Sometimes you will have to go for specific investigation. You will do permeability tests, water sampling and analysis, soil sampling and analysis. You're looking for, is the infiltration still working? Is the water quality good? The water coming, is it good quality? The water going outside of the system, what is the quality? Is the system treating the water or not? Is the soil, what is the pollution of the soil? Many systems are designed to take the pollution from the water, so you need to find it in the soil. And if you find pollution in the soil, it's a good sign that your system is working well. But maybe you have to deal also with this pollution in the soil. And then you start to have longer monitoring. You can have few months or few rain events monitoring, and you will see how the system cope with the rain, what's happening, is it flooded, is the water goes where it should be. And sometime you will need long-term monitoring, more than 1 year, because some impact, like you're looking for impact on biodiversity, on stream, and so on, you cannot see them on the short term. So you will have to investigate on leave a system to monitor the system for several years. So you have to choose what you're doing. If you go only for the visual inspection, the cost is the lowest, but you don't have so much data to work with. If you go for the long-term monitoring, that's perfect. You will monitor your WSUD for several years, and you will have heaps of data. But the cost will be also very important. So you have to choose. Again, balance. Then you will have to assess the condition of each asset based on visual inspection or a long-term monitoring or something in between. Each system is very different. If you look at a swale, a trench, a detention basin, even a swale can be very different. You will have many different components in your asset. So you have to check for each component, and you have to look for the potential failure for each component. This figure is not representing a real asset, but it's representing an asset that with all the components that could be found in an asset. So you can have components related to safety, like the fence, for example. You have components related to the inlet, the outlet. You have the water itself. You have the soil. You may have also monitoring components. So each asset is very different. So when you start to assess the condition, you have to assess the condition of each component, and then you have to know if this condition can lead to a failure. And you don't really care about the condition of the asset. The most important is the consequence. If the asset is in average condition, but for any reason they are flooding, maybe the design was not good. So you have to do something. If the asset is in poor condition, and it's often flooded, but this is maybe in a very specific place and nobody's there and there is no consequence, then maybe you can leave it because it's not your priority. And you know that you won't have enough money to deal with all the problems. So it's a lot about assessing the consequence of the condition, not only the condition. And then you will plan your action. You will decide based on that you have this amount of money, and this can be used to renew this one, renovate this one, repair this one, and then you have to make all the priorities. And this money is also the money that will be used to monitor. So maybe you can decide not to change the system, but to monitor it for more time and to see if really we need to do something. So that's very important, and that's where you can justify all the budget you have. And of course, any infrastructure, any urban infrastructure is shared with many other services. You have to work with them, because if you decide to do something on an infrastructure, you have to know if what the other will think of that and if they can combine the work and lots of things. So you always have to share the knowledge and the decision. It could be green spaces. When you're working with swale in a park, you need to work with the green spaces department or parks. You need to work with urban planning, because if you renew this and then 2 years later there is a big urban redeployment, maybe it was not very useful. You need to work with the road department for porous road and so on. You may need to work with sanitation department also, because sometimes there may be problems with pipe. So that's also a very difficult part of this, to plan the action, but not alone, with other departments. And then when you act, that's quite classical. You may have the routine action, very small and not expensive action, but maybe frequent. Cut the grass, take the litter, wet some plant, water some plant, whatever. And then you have the rehabilitation, which can be small reparation, renovation of part of the system, or the whole replacement of the system by the same one or different one. And you have also all of these non-structural actions that are very important. To inform, to explain what the system is doing and how it's working and how it should work. Maybe it will prevent the misuse, because if you have to go every 2 months to put a new valve in the system, because the inhabitants are removing the valve because they want the water, will be quite not so good for the cost. But if you go and explain them how it works and this system is protecting them, and if you keep the valve, this system will work and protect them, maybe you don't have to come back to put a new valve. It will stay in place. You can also have non-structural action on the way you're managing your infrastructure. Maybe to change practice. Say, I don't use herbicide anymore because of this, of that. So it's not only about doing something. It's also about maybe telling, discussing, and changing the way of doing things. And the last part is very important, is at the end of this, you always need to have this control of what you've done. You're controlling the process, but you are also controlling the cost. Was the time forecast for this action good? Was the cost okay? Was the quality of the work okay? And is the system working better now that we renovate, repair it? So you always have to have this control. If you don't put the control, you don't increase the knowledge on the benefit of your action. And you may do, again, actions that are not very efficient. So the control part is very important. And as Matt can say, on all of this, the data management is very important. And when I'm speaking about data management, it's about collecting data. You need to collect as much data as you can, and you need to balance that with the cost. And you need to validate the data, because the data that is not validated is not useful. And the best way of having good data is to use the data. When a utility is gathering lots of data on their infrastructure, and that's go in the GIS and it's not used, you can be certain that the data is not good. Because if you don't use the data, you don't know what are the problems in this data, and you don't improve it. So it's very important to always think of the use of the data that you are collecting. Is the data used to improve your model, deterioration model, clogging model, whatever? Is the data used to improve the guidelines, how to monitor, how to rehabilitate, and so on? Or is the data used to update your objectives on the expected performance? So it's very important. This data part is very important.